Good morning, everybody. Welcome to class this morning. Let me turn off my microphone just a little bit here this morning. Here we go. Good morning, everybody. Welcome to class this morning. Thank you for joining me, whether you're watching this live or whether you're watching the recording. I appreciate you watching. And as we are approaching today, we're going to talk about PHP today. But I think it's kind of important for us as we are examining PHP to kind of look at some of the things that are surrounding this course as we are quickly reaching the end of the semester. So this week we'll be talking about PHP kind of being our server-side programming or scripting language of choice for this particular class. Next week we'll be examining databases with MySQL. And during the final week of the course, which is the next week after that, that week is for you to kind of pull together your final project, pull together your final exam. So that will be the remainder of our course. So really, we only have 2 more live streams left. That last week when your job is just to pull together your final project. We won't be having a live stream, although we will be having sort of a drop-in session during this time. I'll make myself available to you all just in case you have any questions or anything like that as we approach the final day, which is rapidly getting here, right? Like way back in September when we first started this class, like this time seemed like a long way away. But now, you know, we have 3 weeks roughly left, not even that really, of the course. You know, a 14-week class is now, 11 weeks are gone, and now we are down to the nitty-gritty, if you will. So I do realize that this is the time of the year when everything is due, when everything is rough, right? Because everybody wants final projects, everybody has final exams, and they're all due here right at the same time. So as we're just kind of getting started today, I want to give you a little bit of encouragement just to, keep your head up, keep pushing through. We're almost at the finish line. We almost have that light at the end of the tunnel. Just a couple more weeks to get there. And then you can enjoy the holiday season after that. Speaking of holiday season, it is a holiday week, which means that I'll be out of the office toward the end of the week, right? The college will be closed on Thursday and Friday of this week in observance of the Thanksgiving holiday. So if you go looking for anybody on campus during those 2 days, you won't find it, because everybody will be celebrating the holiday. And this is one of those points where I also like to encourage you. Like if you want to celebrate the holiday without having to worry about anything, one of the ideal things that you might want to do is to go ahead and get stuff done now. Get stuff done for this module early, today and tomorrow. So that, you can take off Wednesday, Thursday, Friday and just enjoy the holiday, spend time with your family or whatever it is that you want to enjoy this holiday season. I know that's different for everybody. But, at least you wouldn't have to worry about schoolwork if you went ahead and got it done this week, which is a positive. But we're talking about PHP today. And PHP is a server-side web programming language, or a server-side scripting language. And just as a little reminder as we're getting into this, right, I want to talk about kind of the differences between front-end or client side and back end or server side. So let's switch this over to some kind of drawing board here for just a couple minutes. And we talked about this previously when we talked about, kind of the way our web works, right? Kind of the way the internet works. We talked about how there are things on the client side and things on the server side. And we talked about these in terms of front end and back end. Right, so remember that the client side, that's you. That's the individual who is requesting the website, right? You'll remember back to Module 2, we talked about requests and responses, and we said that, whenever we go and we type in, www. or whatever our favorite website is.com, and it comes back to us, what's happening there is that's making a request to the server, and the server is saying, okay, here's a copy of those files so you can look at this website. And then your browser takes that copy of the files and renders it out so you can see it. Right, so the process that the browser does, that's our front end. So the server sends you some files. Your browser gets those files. It says, okay, this is an HTML file, this is a CSS file, this is a JavaScript file. I know how to work with these. I know how to load these. Here's what I do. Here's my HTML, here's my CSS, here's my JavaScript. Here you go. There's your favorite website. There it is for you to look at. And so this is all happening on the front end, or the client side. And when we think about front end or client side languages, these are all of the web languages that we've looked at so far. These are HTML, CSS, and our JavaScript. Right, these are the files that our server has sent to our client, and our client or our browser has rendered out on our machine. On the opposite end of that, right, when you make that request, of the server. And the server sometimes does some work on the back end before it sends you these files to kind of prepare the files, maybe to interface with the database, maybe to, do some calculations or do some other work that requires some server resources before it sends you the files. And this is what's happening on the back end. So we have special software on our server that controls this process. Right? Because we don't want things like our database on the front end. Right? Because we want our database to be secure. So we don't want to send any more information that would require data stored in our database, that would require special keys to interact with APIs that we might have, anything that we want to kind of keep secret. We don't want to send those to the client. We don't want to send those to the front end. We want to interpret those on the back end and have something kind of sanitize that and put it into front end language that is okay, is safe to send to our client. And that's where we get into these back-end scripting languages, these server-side scripting languages. And these include things like PHP, which is the big one. It's one of the most widely used ones, as we'll talk about in just a little bit. But we also have other programming languages that we can use as server-side scripting languages. It all depends on what kind of software that we have on our computers or on our servers, right? You'll remember before we talked about a LAMP stack, or we might have termed them as an Xampp stack. And this is the software that's on our servers that's doing this interpreting. And, and specifically here, the one that we're concerning ourselves with is the P, because that's going to be, for our purposes, PHP. But, for example, if you have some other servers, like, if you have like a Django server or a, one of several other types of Python-based coding servers, your backend language might be Python. There's a version of Java for the web that's called Kotlin. That could be a language that you use. then you might have heard of things like Ruby or ASP. Right, and all of these different softwares require some kind of interpreter on the back end, on our server side, to be able to read that code, interpret that code, do anything that it needs to do with the code so it can interface with with the things like our databases and our secure keys and our various other things that we might have on our server that we definitely don't want to reach the client. It can pull data from our database and just put it into the site and then render out a file as HTML, CSS, JavaScript. And that's what it ends up sending to the client. Right? So we call these back-end or server-side scripting languages because all the work that's being done here with these scripting languages is occurring on the server. Right? It's doing the work on the server. It's taking this code. It's making these calculations. It's doing these calls. Everything that it needs to do. And taking that and kind of sanitizing it and converting it into a page that's safe to send. And it's converting it into an HTML, CSS, JavaScript type page and sending it to our client for our front end or our browser to be able to render that onto our screens. So what we're doing here is we're moving from the front end, which is what we've been covering so far, to the back end. And so it's important for us to kind of remember that as we approach this. So I guess the question then would be, well, why PHP? Right? And we'll get to that. Because PHP is one of the most widely used server-side scripting languages in the entire world. And there's one big reason for that. Starts with a W and rhymes with Wordpress. Right? Well, we'll get there in just a minute. The first thing that we kind of want to talk about is just what exactly is PHP. And so PHP is one of those open, it's one of those server-side scripting languages, and PHP in particular is open source. PHP is maintained by a sort of co-op community type of group. It's open source. That means that anybody can contribute to the code base. There is a process, of course, by means you can get your code approved to be a part of the code base. But it is open source. Like, we can go look up the PHP source code. Which, why not do that? Right? Just one quick Google for PHP source code. And here it is on GitHub. Right? This is the PHP interpreter. This is the interpreter that gets put on servers so that it'll interpret your PHP and make it into whatever, you intend it to be. And we look here and we see different files. There's some YAML files. The big important stuff that we would want would probably be in our build file here. And we see some stuff in here for different things. And we can actually look at the source code and get an idea of what's going on here, right? So, obviously, with where we're at, the majority of us, we're not going to be able to look and see, what's going on in here by just clicking a file and then understanding it, right? But we can have a good idea of what's going on. Like, here's a bunch of code. Look at all that code, right? And it's just there for us to see. Which is something that we don't really think about a lot because, even though we've probably heard of open source software, we don't really think about what that means. And the fact that it means that you can go out and see the source code and interact with the source code if you want to. So I think it's kind of fun to look at that from time to time. But it is a general purpose language that you can use to, essentially make anything. A big thing is graphical user interfaces, or GUIs. That can interact with a database. The biggest thing is database interaction. And as we'll mention in a minute, PHP can interact with essentially any database in the entire world. So if you want to connect a database to your website, which you probably want to do, PHP is not a bad play for that. Now, you might hear me keep saying the PHP acronym, and you're like, well, that's an acronym, and technically it's an initialism, because acronyms you pronounce, and initialisms you just say the letters, right? So if it was an acronym, we'd call it PHP or whatever, but we don't call it that, so we call it PHP. So that's an initialism. So the abbreviation, or initialism, PHP, initially stood for personal homepage. P, H for home, and P for page. Doesn't stand for that anymore. And I mean, I think it's pretty clear as to why it doesn't stand for that anymore, because, I mean, really, there's a lot of different ways to make a personal homepage nowadays. So that's a really super generic name for something that you might want to be a little more specific in. And moreover, it really doesn't describe what the language does, right? Like, it doesn't really build your personal homepage. I think the new name, the name that it is now, is more appropriate, although it is kind of weird, right? So PHP does not stand for personal homepage anymore. It's a recursive initialism, or a recursive, we have acronym here, so we can say recursive acronym, even though that's not quite technically correct. It's a recursive initialism for hypertext preprocessor, right? So that's the H and P. So what's the other P? Well, the other P is PHP. So technically, the full name of PHP is PHP Hypertext Preprocessor. And so PHP, the first P stands for PHP, which, that's kind of weird. That is what it is, right? PHP Hypertext Preprocessor. And that makes a whole lot more sense in terms of what PHP does. It is pre-processing some code on the back end, turning it into hypertext to send it over to our client, as we've kind of discussed. So just a little bit about the history of PHP here. PHP was developed in 1994 by Rasmus Lerdorf and his team. It's currently on version 8, which was released November 2020. So roughly a year ago, version 8 of PHP was finalized and put into production. As we could see now, they're on essentially release, they're on 8.1 at the current time. But it's developed 1994. Right, so we're looking at, oh goodness, how long ago would that be now? It's too early to do math on a Monday morning. Right, you stay up late on a Sunday night trying to get stuff done, and then you get up on Monday morning. Let's see, that's 10 years would be 2004, 20 years would be 2014, 25 years would be 2019, so that'd be 27 years. 27 years ago, we got PHP. And we've had 8 versions of PHP between then and now, and that might sound low, right? Like we look at things like the Adobe Creative Cloud, for example, and it's like, oh, there were 10 versions of Illustrator in half of that time. Right, but we look at other things and we see, well, maybe that's a lot. And that shows that, they've done a lot of active updating into this code base. Just like we look at Python, and even though Python has had several really updates over time, in terms of a version history, there have only been essentially 3 versions of Python, 1, 2, and 3. Currently on Python 3. Although there's a lot of little there's a lot of smaller updates in there. But it is one of the most widely utilized server-side scripting languages in the entire world. PHP is. And the backbone of that is, or the main reason for that is that PHP is the backbone of WordPress. The majority of the websites that you see on the internet, even things that you might not even think would be WordPress, are built on WordPress. These kind of content management systems in general. When we look at, WordPress, when we look at Oh, the other content management systems are escaping me at the moment. But when we look at these content management systems, the majority of the largest content management systems are built on PHP. And, for those of you who are in the programming and web development IT degree, you'll eventually get to our content management systems course, where you'll get more of a hands-on with these content management systems and, in turn, get more of a hands-on with PHP. And, WordPress being the majority of the world of websites at this point, really, unless you're looking at something that would be like a completely custom build. You see that on these custom builds, those would be more like our, Web 3.0 social media type sites. Amazon would be custom. Just more of like the regular everyday websites that you see for like your local small businesses, for colleges and universities, for example, because Cleveland Community College is built on a WordPress site. A lot of the smaller sites, basically every smaller site you see is built on some kind of content management system, probably WordPress, and that content management system is more likely than not built using PHP. So there are millions, if not billions, or even trillions of sites that use PHP in some form because they have one of these content management systems that's kind of helping the users maintain and update that site. So we've got some advantages of PHP here. One is that it's platform independent. Two is that it's open source. So you can kind of go in and you can see how it works. Platform independence is great because we can put it on any server with any other type of software, right? Like we looked at those stacks earlier. LAMP, Xampp, Right, that's one example right there, is that we could have it on a LAMP, MAMP, WAMP server. Doesn't matter the operating system. The operating system is going to be able to work with PHP, whether it's Linux, Windows, or Macintosh. It's easy to learn. I kind of put that in air quotes there. We'll find out how easy it is to learn. I think it's pretty easy to learn. It's going to be mostly the same as a lot of the other programming languages that we've learned so far. We're going to be using the same kind of logic structures for our purposes here. So conditionals and loops. And just like anything that we've got kind of in programming, that means being specific and paying attention to what we're doing. Uppercase, lowercase letters, that sort of thing is important. And then it syncs with all databases. Every single database. Whether it's MySQL, whether it's Xampp, whether it's MongoDB, relational, non-relational, doesn't matter. PHP can work with it. So before we get started actually using some of the code, it is important to know that PHP is a server-side scripting language, which means you'll need a server. Now, for our purposes, we'll still be using Replit, because Replit could create a virtual LAMP server for us. Right, the only thing is that we'll have to create our Replit just a little bit differently than we've been creating our Replit thus far. We'll have to look for something a little bit different when we're working with this, but it's fine. Right, we can still use Replit and we can still build sites on it exactly the same as we've been doing. If you want to practice PHP on your own without Replit, you need some kind of Xampp appliance. There actually is a software that you can get and download called Xampp, Xampp, that gives you this kind of server, a PHP server. It'll spin up a little virtual server or a little temporary server on your machine for development purposes. This is pretty handy to have. And we can see the programming languages that it supports here. In this case, it's supporting MariaDB instead of MySQL, which those are pretty similar. Probably just came up with, probably just has something to do with licensing agreements for MySQL. because Xampp is it's a completely free software that you can use to practice development and create your own servers on your own time. But again, we're using Replit, so we don't have to worry about servers. You know, we'll have some other company make a server for us, which is pretty cool. And so the first thing that we'll want to do is we'll want to create the file. And when it comes to working with PHP, our file structure is really similar to what our file structure would be in HTML, CSS, and JavaScript, right? It's essentially exactly the same. We can still have a CSS file. We can still have a JavaScript file. And they'll still interact with our site in the exact same way. The only difference is going to be that HTML file. Because now that HTML file is not going to be something that we're going to be rendering initially on our client. It's going to be something that's going to be interpreted by our server. And then the code that's interpreted is going to be changed into an HTML file of sorts and sent to the client so it can understand it. So the PHP file is interpreted by the server, and the server delivers you an HTML understandable file. Right, so we're going to see an index.php file instead of an index.html file. And so let's start working with this. Let's go ahead and fire up our Replit here. Let me find that window that has Replit in it. There we go. Switch over to full screen here. And what we're going to do is we're going to create a new REPL. So I'm going to go up here, upper left-hand corner, click Create REPL. And this time, instead of an HTML, CSS, JavaScript Replit, I'm going to search for PHP. And when I search for PHP, we see I get two options: PHP Web Server and PHP CLI. CLI is command line interface. Remember that, you know, when we're programming for practicality. So we want to see things that actually work on a website. So we don't want the CLI here. We want the web server. So we're going to select the PHP web server, name it, and click Create REPL. Now, one of the things that we'll see here is we have an example of a hello world here. One thing that I'm going to do here is I'm going to delete that hello world because I'm going to do a slightly different hello world. But we also see that all we have here is an index.php file. So we talked about our file structure, and we're going to want a CSS file, and we're going to want a JavaScript file. So let's add these files to our project, and then we'll show you how to link them in our project because they're not currently linked in there. So I'm going to add a file here. I'm going to call it style.css. It's going to take me to that blank file. I'm going to add another file here, and I'm going to call it script.js for my JavaScript. Now in my PHP, one of the things that you might notice off the bat here with this PHP file is that, well, it looks a lot like our HTML files. Right, we have our HTML skeleton here. We've got our HTML tags, we've got our head tags, we've got our title tags, we've got our body tags. The only thing that's looking a little weird right now is this little bit of code right here in the middle. Now, that's the code that signifies where our PHP goes. Anything that goes between these two tags, which, you know, they're not really tags, but they are kind of tags. Anything that goes between this less than question mark PHP and this question mark greater than, anything that kind of sits into that container is PHP, and it's going to be interpreted by our server as PHP. So let's link our script.js file and our style.css file here. We'll start with our style.css file. These are things that you didn't have to do in your HTML, CSS, and JavaScript examples because Replit did it for you. But here we're going to link So we're going to add our link tag. Rel equals style sheet. href equals, and since this is in the same project directory, I can just put my file name here, style.css. So now I'm linked to a style sheet here. So let's just cut this out for a minute just to show you the example. All right, like if I go here, cut that out and go into my style and type body, background dash color is red. Right now my style sheet's not currently linked in this PHP file or HTML file. So when we run this, it'll give us some code and it'll give us our page here at the top. You see the page is white. Now, one of the things that we need to realize about our PHP file versus our HTML, CSS, JavaScript files that we were working with previously is that when we click that run button this time, it is spinning up a virtual server for us, not just rendering some files, right? So you see that when I clicked run there, it didn't run for a minute and then change back to run. It's now a stop button. Because what this has done is it's created a server for me, and that server is running as long as my replit is running. So if I need to refresh the code or do something different or stop the server at the end of programming with it, I need to make sure I click stop. So now I'm going to come back in here and add that little link, that link rel style sheet href equals style.css there. And we can run that now, and we can see now that our site is red, right? And that's because of our styling the body here. So it doesn't work unless your file here knows that that style sheet exists. And we'll do something similar here with our JavaScript file. We use different tags for these, right? We link our CSS, but we put our JavaScript in script tags. So to add our JavaScript here, we're going to add some script tags. We're going to put the src as the link to the file, which is script.js. And then we will close our script tags. So now we have this JavaScript tag in our PHP file, and we have this CSS in our PHP file. Let's stop that. Let's remove that body color there now that we know everything's working. Looking good. And that's what we're working with. Right, this is our PHP replit. So we said we were going to do a hello world here. We were going to do it a little bit different. So let's look at our hello world. Right? In every other language that we've done so far, we wrote a hello world, right? In PHP, or in Python, we did it. We did something similar in our block logic when we were doing that. In JavaScript, we did it. In basically everything we've done so far, we've done a hello world. So we need to do one in PHP while we're at it. And so here's essentially the example that we're going to be doing. Instead of the echo, which you saw there by default, we're going to be using the printf function, which is a part of the print family of functions in Python, or in PHP rather. We'll talk about the difference between those in just a moment. But we can see here, we just, in between those tags that we talked about earlier, we put printf, or just print, or whatever, a pair of parentheses, a pair of quotes, and inside those quotes, we just write HTML. Right? In this case, we're putting a paragraph that says hello world. When we do the example, we use an H1. We could even put a class in there. One of the most important things for us to kind of notice here is this bad boy right here, this semicolon. In terms of programming languages and how they feel about us, JavaScript likes us. Right? You know, in JavaScript, we talked about how we wanted to use the semicolon as a means to end our lines, to let our interpreter know this is the end of this line. The next line starts, with the start of the next line. And while JavaScript has its quirks and it doesn't really like to play nice with like error messages and things like that, I don't know that I would say that JavaScript actively hates us. PHP, on the other hand, I believe actively hates us. You need to put the semicolon at the end of your line in PHP, right? If you didn't put it in the end of every line in JavaScript, sometimes JavaScript would let you get away with it. PHP does not let you get away with it. PHP will pitch a fit if you don't put that semicolon at the end of the line. Now, there are some other things that PHP does that's a little bit more friendly, like things like, how we can include variables. We can include variables in our output in many different ways. But one of the things that it is very strict about is making sure that we put this semicolon at the end of every single line of code we write. Or else it'll grab us and shake us and say, no, that's wrong. PHP actively hates us. So let's head back over to our replit and write a little hello world here. So you'll notice I'm in between that opening PHP and that closing PHP. Right? Less than, question mark, PHP, question mark, greater than. In between there, I'm going to write my hello world. And we're doing a printf function here. So it's going to be printf. And in quotes, we're going to put h1, hello world, \h1. And we're going to make sure that we put our semicolon at the end of the line. Now let's talk a couple things about this here really quickly. When we're putting something in here like this as well, this is another place where PHP hates us. Double quotes. Whenever we're wrapping a string like this, we wrap it in double quotes. Now this is kind of a curse, right? Because we might be used to putting single quotes on lines like this, but it's also kind of a blessing. Right? Because one of the things that makes it easy to do is add things like, say, a class. Or an ID. Right? Like in this case, I wrote an ID of hello. And when I wrapped hello there, I wrapped it in single quotes. So we need to wrap our main portion of our code in these double quotes. But if we need to put any quotes inside of that, we can use single quotes, and it's going to be nice to us. It's going to be friendly to us. Right? We just have to follow its strict rules. Right, so now if we run this, we'll see we have a hello world here on our output. And we'll even pop it out into a new tab just so we can see it just as a whole site. And now the thing is that what we've been sent here is technically HTML. Right? Notice all this code we've written here. If I go to this page and I right click and I say view page source, what we see here is just the HTML. Right? None of that PHP is there. Because remember, that PHP was interpreted by the server, converted into this HTML, and that was what was sent to us. So now we can interact with this just like we would interact with regular old HTML, right? So if I wanted to, say, write some CSS for this to make it special, I can just go into my CSS file, target that, what did we call that? Called that ID hello, so I can target that ID of hello, so that's hashtag hello. And just add some CSS rules here, like maybe font, family, Verdana, Geneva to Homo sans serif, color. Maybe we can make it a nice, let's make it a nice brown for Thanksgiving, shall we? Maybe something like, 80 40 00. A nice Thanksgiving autumn brown there. And so when we stop and run our server, we'll see that we get those results there. So we don't have to do anything special for styling. Because remember that the styling happens on the front end. The styling happens when it gets sent those files by the server. So our server is just taking that PHP, it's converting it to HTML. It's sending that to our browser. And then we can use JavaScript, CSS, anything that we would use on the front end as we normally would. Right, so that makes life a whole lot easier. So now, one of the things that we've seen here that I think we should probably clear up is that when we loaded our replit, it gave us a little template there, and it gave us, in our template, it gave us an echo statement. And then we changed that out, and we used a printf statement instead, which again is a part of a group of statements that are print statements. So let's talk about the difference between echo and print. PHP allows for two methods of sending output to the screen. One is called print, and the other is called echo. And so they provide the exact same functionality. Right, so for our purposes, for the scope of this course, they're exactly the same. So if you want to use echo, or if you want to use print or printf, fine. No problem. They're all going to work exactly the same. Like when we get into efficiency and things of that nature, we look at print and we look at echo slightly different. Echo is a construct, so it'll be treated like a command, where print is an expression, so it'll be evaluated and it'll return a value, which would mean that echo is slightly more efficient than print would be. Just because of like the computations that are going on when they're ran. But the difference is negligible, right? And for our purposes, we can kind of do whatever we want with it. Here's just an example of that. We also saw this same example basically when we fired up our replit there, right? It put that echo out there for us. And, you know, one of the things that you might see different here versus what was in our replit is that this has parentheses, whereas our replit didn't. Both of those will work. I prefer using parentheses since that's the majority of what we see in other programming languages. Parentheses there, like there's a lot of things where we have, A, B, or C, or D, or all of these will work in PHP. But I have preferences in terms of what I think looks nicer and what I think can help us make better sense of code. So I like to put parentheses around my echo statement, even though you don't have to. One of the things I'd like to show you really quickly is this idea of server information, which is one of the ways that this could be kind of insecure. You know, the fact that we can run this Php Info function and this will return a bunch of information about our server, what version of PHP is running, what the operating system is on the on the server, all this sort of stuff, right? And so we have this PHP function, we can echo it, and this will provide us with a lot of good information, which could be really good for us, right? Like if we are going into a new project where we have an already existing site, we can echo this PHP Info function, and it'll give us all this information about, you know, the type of server that we're dealing with and all that kind of stuff, which would be useful to us when we don't know what's going on. But it could also prove to be useful to people who are trying to unlawfully access information on our server. So it is something to consider here, right? But we look at this, we just echo the PHP Info function, and it'll provide us that information. And we can even add it to a site that already exists, right? I can just go down below this printf and I can echo PHP Info with the parentheses and the semicolon at the end. We'll stop the server, we'll run the server, and now we see this version information here. Let's pop this out into a new window so we can get a better look at this. And we can see here, okay, we've got a Linux server, Ubuntu. See the version number here. We see when the server was originally built, since this is a virtual server, that was when it was originally imaged. We can see that virtual directory support is enabled. We can see the path to our configuration file. We can see the version number of PHP this is using, 7.4.21. We can see all the registered PHP streams here. We can see a lot of information here. And if we scroll down the page, we can see that there's tons of information here. And this is information that we can use. We can use it for good to see how a server that we have already existing can be helpful to us. But you know, if we made this page or we ran this command and we left it on our server, somebody found it, right? This could also prove to be dangerous. So for example, if I just open up a new tab here and Google PHP, what did we say? It was 7.4.21 vulnerabilities. Well, what do we have here? Right, so within one quick Google search, I can find a whole list of PHP vulnerabilities. And there's a bunch of them, right? Like I can look at pretty much any of these sites here. CVE details, I think, is the, yeah. On this site, I can see these vulnerabilities. I can see, you know, if I click one of them, I can see what I have to do to take advantage of that vulnerability. It even has a complexity here. And we can see all of the vulnerabilities. So if we want to test this, that's fine. But one of the things we probably want to do is remove that when we're done, to just make it a little bit harder, right? Like we're not making it much harder there, but we're making it a little bit harder. On our users to, you know, get information that could compromise our server. So let's really quickly look at some of our data structures, or not data structures rather, but logic structures here that we would need to be able to do some more advanced programming. And we're going to examine the same logic structures, and I'm going to do as many of them as possible here in the live stream. Remember that, you know, there's material in the Blackboard that covers the ones that maybe we don't have time to get to. But we're going to push, and we're going to try to do as many as possible here. And the first one is the variable. Right, so variables store data for later use, and they allow their contents to be updated and changed. We've talked about this ad nauseum in the past, so we won't get too deep into it here. Just as a quick reminder, you know, remember we've talked about variables kind of being these containers that we can put data into, take data out of, and one of the most important things about variables is that we can put a label on them. We can name them. And by means of naming a variable, essentially what we're doing there is we're creating this symbolic link between the name of the variable and the data that's contained inside the variable. So that if we want to refer to that data later on, we can refer to it by its container's name instead of the data itself. So that's the big deal here. Now, PHP in general, pretty much exactly the same as declaring a variable in every other language that we've discussed. PHP is loosely typed, so we don't have to declare a data type here. We haven't had to worry about data types all semester. We won't have to worry about data types until next week when we talk about databases. The only real big different thing is that when we're talking about a variable in PHP, we have to include a $sign before our variable name. And that $sign is kind of like, when we were working with JavaScript last time, we would write the word var, V-A-R, before the variable. Putting this $sign right before the variable name, no space, is an indicator to PHP that this is a variable. And one of the other differences regarding variables in PHP is that in PHP it doesn't actually create the variable until it has a value. In other programming languages, things like Java, Python even, I think JavaScript even does it as well. You can declare a variable by just typing in var or int or whatever the syntax is for that language and putting the variable name there. And then that variable will exist in the code. The interpreter will establish that container. There just won't be anything in it. In PHP, the variable isn't created until a value is assigned to it. So we need to have an assignment of a value to establish our variable. And so we can see that here. We just have a few examples of that here. We have x equals 1500, y equals 3.1415, z equals cheese, right? And notice there that we have $x, $y, $z, because in order to be recognized as a variable by PHP, we have to have that $sign there. And this also does a good job at showing that PHP is loosely typed. As you can see, there's absolutely zero syntax difference between these three variable declarations. Right, the only thing that's different is the name that we put onto the variable container, that label, and the value that is put inside of it. So like the first one's an integer, the second one's a floating point number, the third one's a string. And there's no foundational difference. So we could look at, let's look at some variable naming rules before we look at creating one in our program here. Variable names must be preceded by a $sign. We've said that. Variable names must start with a letter or the underscore character. The underscore character is the only symbol besides the $sign at the beginning that is allowed in a variable name. Otherwise, it can only be letters and numbers. And you can't start it with a number. Because remember, one of the things that we've said in the past is that as our interpreter is going through, if it sees a number there, it's going to think, oh, it's time for me to do math. But then it's going to immediately see something that's not a number, not some kind of mathematical operation. So it's going to be like, what's going on here, and throw you an error. So it has to start with a letter, has to start with an underscore. The name itself can only include alphanumeric characters and or underscores. And just like everything else that we program, it's case sensitive. Uppercase and lowercase are different. So we have to pay attention to what we're doing. So let's create a variable in our program here. I'm just going to go here right under my starting PHP area. And I'm going to create essentially this hello world text as a variable. So that's going to be $sign hi, let's say. And we're going to set that to hello world. Or you know what? Let's change it to something different just so we can tell that it's different, right? We'll say, how's it going, world? Right, and so now when we're inserting this into this print statement, one of the best parts about this is how we insert our variables into a print statement. It's a lot easier in PHP. We don't really have to worry about concatenation or mostly special symbols here. What I'm going to do is I'm going to put my $sign. And really, I can just put the name of the variable here. I can just put $sign hi here, and it'll come out on the other side. But what I like to do, just to kind of make it stand apart, is I like to put curly braces in here. So this will be $sign hi. So $sign open curly brace hi, closing curly brace. And that's the reference here that we're tying. So this here is this here. They're tied together. So now when we stop our server and run it again, oops, we had an error. What was my error? Remember that PHP hates me if I don't put a semicolon at the end of every line, right? This was intentional to get you to see just how important it is to put that semicolon at the end of every line, right? In Java or in JavaScript last week, that would have worked. That would have been just fine. It have said, I get what you're trying to do here. Everything's cool. Do your thing. PHP hates me. So let's run that. And we'll see our servers firing up here. And we get, how's it going, world? So everything is fine. Everything's working for us. Pretty cool. So now let's look at some PHP conditionals. PHP, like the languages that we've kind of discussed previously, allows us to use conditionals to allow our program to make decisions. And PHP utilizes if, and else statements. Right? So for example, we've looked at if statements before. An if statement takes an expression as an argument. If the expression evaluates to true, it'll run the code that's associated in that block. If it evaluates to false, it'll skip its associated code. Right? So for example, we have this example here, if x is greater than 20. If that's true, which in this case it isn't because it's 10, it'll run this code here, which in this case we have another example of how we can integrate a variable into an echo statement, right? Multiple different ways that we can do that. Then we have another if statement here. If x is less than or equal to 20, it's within limits. So in this case, we would expect an output of 10 is within limits because our variable x is equal to 10. And 10 is less than or equal to 20. Now for our example here, I'd like to pull something else into this. Just to do something just a little bit different. Something that we haven't really done in anything else. I'd like to find the length of the string that we're working with here. So what I'd like to do is I'd like to find the length of the string and then do something different with my string here depending on how long it is. And in PHP we have an strlen function, which stands for string length. So if I go into my printf function here, I can add, well, the better way to do this would probably be to put it as a variable. So let's create another variable. We'll call it $, string underscore length. And we'll set that equal to the strlen function of hi. So what that's going to do is it's going to count all of the characters, including any symbols and spaces, in this string. Right? So if I printed this out to my console, or to my page here, rather, stop it and run it, you see we get 22. There are 22 characters, including spaces and symbols, in hi, how's it going? So what we could do is we could take that and we could use that in a conditional. Right? So we could say something like if string length greater than 20. Right, in this case it is. In another case it might not be. And then from here, our conditional looks exactly like it did when we were working with it in JavaScript. So we'll just do that. And we'll just print hi again. Or we'll print the variable itself. So that'll be $hi. And then we'll also print the number of characters there. And we can even put some kind of text in here, like, and just have it say characters. All right, so now we know that's true. So we can stop this, we can run this, and we get how's it going world, and that's 22 characters. But if this was something less than 20 characters, if it was just, say, hi world, we get nothing, right? Because that statement doesn't evaluate to true. So since that statement doesn't evaluate to true, it evaluates to false, skips it, moves on to the next thing. Right, so speaking of the next thing, what would we need to do to get to that next thing? Well, maybe an else statement. Right, so for an else statement, that's for every other condition. So if our first statement isn't true, then our else statement is going to be true, and that else statement will execute its code. So let's just go ahead and add that into our code here. An else statement. Just a moment. An else statement here. So let's swap back over to this. So now we have our if statement. We'll also put our else statement in here, which is just the word else. And in here we can print what it would be if it wasn't greater than 20 characters. And we could just print f. This is less than 20 characters. So now if we stop that, run it. Whoops, what did I do again? No semicolon. Now we have this is less than 20 characters. Which is pretty cool. Right? Pretty cool. So what if we have some other condition that we want here? What if we have some other condition that, you know, maybe if it's greater than 20 characters, maybe if it's less than 20 characters, what if it's 20 characters exactly? Right? Then that's not covered by our if statement. It's also not covered by our else statement currently. Well, it is currently covered by our else statement, but what if it's 20 characters exactly? Well, then we can use our else if statement. And with our else if statement, we can basically, you know, insert another condition in there. For example, if it's equal to 20, you know, it's another block that we kind of have in there that we can use. So let's just insert one of those in here. We'll just put it in the middle here because it has to go between our if and our else, right? So if it doesn't meet our first condition in our if statement, it'll skip to the else if statement. We can put as many else if statements as we want. Else if. We'll say string.length or string underscore length equals 20. Remember that 1 equals is for assignment, 2 equals is for checking value. We will print F, this is 20 characters. So now we can just adjust the value of our hi world here. Let's do something that is 20 characters. So that would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Run that. Oops, what did we do again? No semicolon. Fix that. This is 20 characters. Right, so if we add one more, that makes this first condition true. So we get that. If we take away 2 to make it less than 20, that gets us our else condition, which works pretty well for us. Let's do some loops really quickly. Let's do an else loop really quickly, just to kind of wrap us up today, or rather a for loop. Let's do a for loop really quickly to just kind of wrap us up today. We have our for loop. Our for loop is going to look exactly like our for loop in JavaScript, right? We have our variable name. This is our iterator variable, x equals 0. X is less than or equal to 10. That's our condition. And then we have our iteration here. In this case, we're using x++, which is incrementing the value of x by 1 every time. So in this case, it's going to echo out each time through the loop. The number is, the first time it loops through, it'll be 0. Second time it'll loop through, it'll be 1. Third time 2. Fourth time 3. So on and so forth. So what I want to do is I want to show you a little example here that we can do. And again, remember, there's stuff in your module. We'll just create a little for loop here. For. Let me zoom in a little bit here. $x equals 0. Remember that semicolon. X is less than 10. X plus plus. And then our curly braces to encapsulate our code. So now what we'd like to do here is let's also put in a conditional statement in here. So we'll say if $x plus 1, or we'll say $x. If $x is less than 6, or you know what, we want it to be 5, because I want to do numbers 1 through 5 as something, numbers 5 through 10 as something. We will echo or print, let's echo this time, echo actually, let's start at 1 just to make this easier on us. And we'll say less than or equal to 10. Which will mean if x is less than or equal to 5, we will echo p class equals red. And remember that we'll put red in single quotes here, red. And we'll just put the value of x in between it here. So that's $, curly braces, x, curly brace, and close that p. Don't forget to put our semicolon at the end here. Else, we're going to echo the same thing, except this time it'll be blue. Our class will be blue. So this means that all the numbers less than or equal to 5 will be red. So 1 through 5 should have a red color to it. 5 through 10 or 6 through 10 should have a blue color to it. Now, in order for this to work, we actually have to add these classes to our CSS. So we'll add a .red and make that color red. We'll add a dot blue and make that a color blue. And we can even make these bigger, like if we take and we use our asterisk selector, that'll apply it to everything. We can say font, family, that Verdana, sans serif, so on and so forth. Font size, maybe 24 pixels. All right. So now when we run this, we'll stop and we'll run. It'll take a minute for our server to get fired up here. And we see 1, 2, 3, 4, 5 is in red. 6, 7, 8, 9, 10 is in blue. So it's running through that. And so that's where we'll stop for today. We're about to hit our hour 15 mark. So that is where we'll stop for today. We'll hang out in the chat for just a couple minutes, just in case anybody who is watching live with me here has any questions. Remember that this material is also covered in the module. So in the module, you look at, we have extra stuff on PHP Conditionals and PHP Functions in there. Although you'll find that they're not a whole lot different than our JavaScript. But that's all that I have for you for today. If you are watching this later on and you have any questions, please let me know. Thank you for watching, and we'll see you next time.